Hey everybody, today I just wanted to do a quick kind of training and intro to queues in LabVIEW. So if you've never used queues before, these are found in the synchronization palette, and there's this queue operation. So this is all of our queue functions. Now what queues are is a way to transfer data in LabVIEW in a buffered fashion. So we basically can define the data type and store that data in a buffer that will output data in like a first in, first out order. So this can be really useful for example, if we have like a loop that's reading data off of like a data acquisition device or some instrument, and we want to send that data to like a separate loop that might be logging the data to file. The pulling data from the device and the logging to file could be happening at different rates, different frequencies, but we don't want to lose data in that process. So we can use queues as a way to basically buffer that data and share it between different loops. I'm going to show you guys how to use these. So first we have this obtain queue function. The main thing we always have to wire is this element data type. So our queue can be basically any data type we want. So I'm just going to wire in a string. You can see I no longer have a broken arrow. So that's the only required thing. I just need to connect a data type to it that tells it this is the data type of this queue. So you can't mix and match data types on a single queue. You can have as many queues as you want though in a LabVIEW application, but you do have to specify the data type of that. There is also this option for create if not found. So this comes back to this top terminal that's named name. So one of the cool things with queues is we can create named queues. So I can say, call this, demo queue. So now I've named it and I've defined the data type. So there's this create if not found, which is set to true. So if there is no queue that exists that's named demo queue, it's going to create its own queue. If there is one that is named demo queue that it can find in memory, it's going to connect to that queue and pass out a reference for that queue. So this can be useful if, for example, I have some code up here that's maybe reading the data off of an instrument and putting that data in a queue. I can have a separate thread down here, and without having to actually run the wire, I can just connect to it by name. So a different option instead of just connecting by a wire. You also have this max queue size. So by default, it's set to -1, which means unlimited. So it's going to allow any amount of data in the queue. So in general, you're going to want to bound this, or else this can just fill up and fill up and fill up until you run out of memory. So for example, if you had a data acquisition loop and a logging loop, and you were using a queue to pass data between the two, and for whatever reason your logging loop froze up, or maybe the process actually terminated entirely, your data acquisition loop is going to keep putting data in that queue, and eventually you'll hit a point where you run out of memory and it doesn't work anymore. So it's case by case, right? But by default, -1 just means there's no bound to it. Especially when you're working on RT targets like compact Rio, you're really going to want to bound this so that it can't run away from you. So from there, we get this queue out. So what this is this is actually a reference to the buffer. So one thing I see a lot of newer developers struggle with is we can branch this off, connect it across different loops and whatnot, and that confuses a lot of people because we might be writing to it here, but before we actually started writing to it, we branched this off. So just know we're not actually passing data along this at all. This is just a reference to the actual buffer that's kind of in the background. So yeah, this isn't data, this is just a reference. From there, we have our enqueue function. So this is how we're actually going to put data into the buffer. So basically here, we're just inputting an element. element 1. And then there's also this optional timeout. So this just basically, if there's no room in the buffer, it's going to wait until either that amount of time has passed or there is room in the buffer. So if we have this set to unlimited, this is never going to wait because there's always going to be room. But if I had this, for example, set to 100 and I already have 100 elements in the queue, this is now going to wait until either that amount of time has elapsed, which -1 just means wait forever, or space becomes available and now I can put this in. So that's your enqueue element. We have this preview, which is a way you can basically see what is the element at the front of the queue without actually pulling it out of the queue. So I'm going to show you the dequeue element function in a second, but basically that pulls the item in the front of the buffer out, and then it's gone forever, right? It's out of the queue. This preview queue element function is just going to say, hey, what's at the front of the queue, return the actual element, but it's not actually going to pull it out of the queue. So this can be helpful just to see if, hey, what's the next command? I use this very, very rarely. We do also have this get queue status. So this is a way to basically get information about your queue. So if you want to know what name it is, you can do that. You can also see the queue size. And one of the most helpful things is seeing how many items are in the queue. So I can say, hey, there's 50 items in this queue, or whatnot. So it can be useful as well for like benchmarking, because maybe we want to always keep our buffer size really low. We can see, hey, is this buffer starting to just run away, right? Like we're putting data in faster than we can get it out. So this can be a helpful tool to kind of check that. We have this release queue function, which will just be used basically at the end of when we're done with this queue. It's just releases the reference. So if the reference only exists in one place, it's going to destroy the queue for memory. If we've called it by name multiple places, it's going to wait. It'll destroy this specific reference, but if it's still being used other places, it will still be accessible. This will just be kind of our shutdown code. There is a lossy enqueue element. So this is a way you can create a lossy queue, which means basically we can, let's say we've defined our size to 100. This is a way that we can create basically a circular buffer of 100 elements. So rather than, if the queue's full, rather than waiting until there's space to insert, this is going to replace the item in the front of the queue with the new element. So as the queue gets full, it'll basically start replacing the thing that's been in there the longest with new data, and it'll just do that kind of cyclically. So it's a good way to create like a circular buffer of data. We do have this enqueue element at opposite end. So this is a way to, like I said, queues work in a first in, first out order. This is a way that you can kind of bypass that. So I can insert something to the very front of the queue. So this can be helpful, for example, if I'm sending like a shutdown command or something like that. I don't want it to have to iterate through everything that's in the queue before it gets the shutdown. I want it to just shut down. So this way I can basically force that to the front of the queue. The dequeue element. So this is a way that we can pull data out of the queue. So this is just going to pull whatever's at the front of the buffer out. So yeah, pretty simple. It's either going to wait however long we specify, or report a timeout, or pull the element out of the queue if there's data available in the queue. The last thing I wanted to show is you have this flush queue, which is basically just going to pull everything that's available in the queue at the moment. So there could be 100 elements in the queue. I could use the dequeue element. It'll pull out one element at a time, and I could iterate through. Or I can use this flush queue, which is just going to return everything that's in there right now. So kind of up to you on what you're trying to accomplish. But that's pretty much it. That is queues in LabVIEW. So if you're interested in queues, stay tuned. I have a separate video about to upload that will basically walk through design patterns that use queues. So specifically, we're going to talk about queued message handlers, and we're going to talk about producer-consumer design. So if you're interested in this and want to learn more, stay tuned. That will be out shortly as well. Thank you. Bye.
Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.